Good morning, friends. Welcome to the session 4 of Spring Cloud Microservices. Thank you for watching the earlier sessions as well. In the earlier session, in the session 3, we discussed about how two microservices communicate with each other. So like A microservice communicate with B in a synchronous fashion, like A sends message and waits till B responds. We have seen various patterns in that and what are the merits and demerits we have discussed. Now we are going to discuss about very another important pattern. We call it say asynchronous communication. So like A sends message to B and it doesn't wait till B responds and A proceeds on its own. So we really A like sends message, fires and forgets. It doesn't care about whether B read it or not or something like that. It's not its responsibility. So this pattern works in multiple places when you have a non-transactional nature of communication. This pattern really works. So I'm not going to dwell into on which scenario you have to focus on asynchronous, which scenario you have to focus on synchronous. There is a good literature on internet, you can go through it. The main focus of this session is I'm going to help you how can you achieve asynchronous communication between microservices. So this is one of the in between microservice communication pattern using asynchronous nature. So um, one thing we have to remember is A sends message to B and it doesn't wait whether B reads it or not. This can be achieved with a messenger in the middle. Okay, you want a man in the middle to do this nature. That is called a messaging system. We'll have one messaging system between A and B and we can achieve that pattern. So RabbitMQ is a very popular message bus or messaging system. In this session, I'm going to cover how do you achieve asynchronous communication using RabbitMQ between the microservices. Then next session, I'm going to cover about Kafka is also one of the popular message bus. So in this session, we'll focus on RabbitMQ and Spring Cloud Stream, okay, a framework to communicate with the messaging systems. Like we use JDBC to communicate with databases, right? We really don't care what database it is. If you write with the JDBC specification, then if you in future if you take from Oracle to SQL Server or some other databases, it's very easy. And think in similar lines. Spring Cloud Stream is like an abstraction on top of underneath message system. So today you are using RabbitMQ. In future, you want to go to Kafka or Apache project, some message infrastructure. Your Java program shouldn't change. So that's one of the goal of Spring Cloud Stream, and which is like easy to understand. You really need not to know nitty gritty of the message bus infrastructure. So without wasting much time, let's jump onto the whiteboard. We will discuss about what is asynchronous communication and little bit of vocabulary you have to know to best understand this tutorial. Okay, focus on the vocabulary, what I'm saying. Okay, then a small example which I'm going to show you how an asynchronous communication works. Okay, uh, so let us let us go on to the vocabulary. Before that, let us learn the vocabulary with a whiteboard presentation. So now, so if A okay, A communicates with B in a synchronous fashion, like A waits till B responds. That is synchronous, you all know. A async means, okay, A sends message to B, but it won't wait. It proceeds further. So async is like it sends, it fires and forgot. It doesn't care whether B is reading it or not. Okay, who reads, who is the reading party also, it doesn't care. So this is one of the good pattern so many people uses, and it is also proven pattern. So how do you achieve this is like A give to messenger, or few people call it say broker, some guy. Okay, you won't talk to B, you give to the broker and broker gives to B, right? So and broker gives that message to B. So broker is someone is speaking on behalf of someone, right? So A gives to broker, messenger, or people call it as a message bus. Okay, So A gives to message bus and message bus gives to B. So the other terminology, what we call A, we call it as a producer, so which is producing the message, right? So and B we call as a consumer, which is consuming the message. So a producer is producing message and consumer is consuming the message. But never producer know who is the consumer and consumer never know who is the producer. So he is the guy in the middle, is doing all the magic. We call him as a broker. So broker takes care of that. So producer produces it and consumer from broker. Broker, we have another term called as a queue. Okay. So think like queue is like a queue. We put message into the queue. So A puts message into the queue. I mean, gives to the broker. Broker puts into the queue, and broker reads from the queue and give it to the P. So you understand queue. Queue is nothing but queue of messages, like one by one message comes. So messenger reads and giving it to B. So like, what is a queue? First in, first out, right? So any message that comes first, that is going to go to first out. So that's what a queue. So a few more terminologies very specific to RabbitMQ you hear. So I feel that you need to understand that as well. Now you know producer, consumer, queue. Now the next terminology what RabbitMQ use is like exchange. Okay. So what is an exchange is like a RabbitMQ manages multiple queues. So if there are multiple queues, exchange route request to which queue it needs to go. So like exchange is nothing but a routing, like it exchanges messages. So when a message comes to exchange, it has to go into which queue the exchange decides. So exchange is nothing but a routing component in the RabbitMQ. So exchange takes the message based upon message attributes or some other parameters. It has to route it to which queues exchange take it. Now you understood queue, exchange. Now you have to understand channel, another term. So channel is nothing but a flow of messages. You can think like a connection, a virtual connection. Okay, a channel where you put a channel will have an input and output. Okay, so output is like input is like someone reads the message, output is someone writes the message to it. Okay, two channels. Output channel is like you will output message to it, you will write message to the output channel. Input channel is something like that you read message from input. That is a very important thing you have to understand. Input is for read and output is for write. So this one difference you need to understand. A channel is nothing but think collection of mm, uh, connections. Okay, it's nothing but a collection of virtual connection. Channel, you can think in it as a virtual connection. It's not really a TCP connection, it's a virtual connection where a channel will have input and output channels. So input you read and output you write to the channel. So that's nothing but a little bit abstraction on top of queue. You can think in that panel. Okay, so any other terminologies that I missed? Okay, so binding is nothing but bind. There is, I always get confused. Okay, so binding is nothing but binding a queue to an exchange. So am I right? Let me check back my documentation once. Okay, binding is a link you set up between queue and exchange. We said, right, exchange is nothing but routes request to the queue. You should establish that binding, right? So that is what called binding. Channel, you understood, is a virtual connection which has input and output. Similarly, connection is nothing but a simple TCP connection. So these terminologies which you need to understand RabbitMQ system. Okay, but if you are learning Kafka, there is no exchange terminology. Okay, all it has is like a broker. You already know messenger, broker. Then you have producer, consumer. The terminology is slightly simplified there. So this is about RabbitMQ message system terminology. Now there is, I said to you, right, we are using Spring Cloud Stream. Spring Cloud Stream abstracts underneath message bus. It can be RabbitMQ, it can be Kafka, it can be anything. So if I draw it in a pictorial fashion, okay, like Spring Cloud Stream abstracts the message bus. So you have message bus, right? So if you give to Spring Cloud Stream API, it writes to message bus, it reads and gives to our Java programs. So that is how the abstraction, the underneath message bus, like message bus is a very complex system. It uses their proprietary protocols, okay, on I think advanced message queuing protocol used by messages, AMQP or something like that, okay. Message bus, Kafka uses its proprietary. You really need not to know about their underneath the protocols. All you need to know is like Spring Cloud Stream library and its vocabulary around it. Then underneath infrastructure is already taken care for you. Okay, so now let us learn few vocabulary in the Spring Cloud Stream. Even fairly, to be honest, even I confuse multiple times. Don't worry about it. It's very common. Refer the documentation every time, and it's hard. We just forgot, but that's fine. If you have a small reproducible code, we are all good. So now the first thing what we have is the channel. Channel in when you come to Java, right? The channel is like an interface, like it has input and output. So channel, the same channel, but it's nothing but a collection of interfaces, okay, input and output interfaces. So where you write into input, sorry, where you read from input and write it and use write interface to output interface to write. So I think fairly that is what uh, a channel is. I documented in my conf page, okay. So sorry, I said it in other way, I totally wrong, okay. Binding is a collection of interfaces which is like input and output channel, okay. I'm extremely apology what I'm saying. That's what I said. I also get confused, right? Binding is nothing but collection of in Java, right? If you want to speak with some external party, you always use interface, right? You don't, like JDBC is a collection of interfaces. Similarly, messaging systems, similarly servlet API is an interface. So you use the interface to communicate with external party, right? The similarly binding is nothing but a collection of interfaces, which is like input and output channel interfaces. A channel is nothing but a pipe. A channel is nothing but a pipe between your middleware. I mean, few people call message bus as a middleware. Okay, it's a pipe between middleware and your Java application. Stream listener is nothing but a listens to the incoming messages, and you write to a channel and you read from a channel. Bindings are nothing but collection of channels or interfaces. So that's a one small terminology mistakes which I made, but don't worry about it. I'll explain you very simple fashion how do you do that. Now let me go back to my entire environment, okay. So how I'm doing this. So i'm having I'm having windows 10 as my base OS. Then I have a virtual machine, okay. I have CentOS 7 as a virtual machine, Linux based virtual machine. In that I'm running Docker Compose. So this is Docker. Inside Docker, I'll run. Inside Docker, I will run RabbitMQ. So this is what the actually RabbitMQ is running inside the Docker. So that is very easy to stop, start. I'm not going to cover what are the advantages of Docker, but that's very easy to run your Docker. So these entire configurations are available for you. I'll teach you how to get. Only a few things which you need to understand here is like, so Docker. RabbitMQ binds to two ports 5672 and 15. So these were the two important things which you not to know. So 5672 is the port where Docker points. So we forward that port till to Windows host 5672, and similarly another port what we forwarded is like 15672. So that this is used for admin UI, like admin UI. They have a UI interface where you can see what is the status of messages and stuff. And similarly, they have a 5672 port is for the communicating with RabbitMQ. You have to send messages, right? The messages goes to this. So now I have two microservices. One is like report API, and another one is like mail client. These are the two microservices now. They are going to communicate within asynchronous fashion. So both of them has to speak with whom? With 25672 port. That is what both of them will speak to RabbitMQ. They don't interact with each other on a particular queue. So report API sends message to one queue and mail client reads the data from one queue. What is the queue? We will call it an email.queue. Okay, this is a common queue where both report API publishes and mail API reads from it via RabbitMQ. RabbitMQ is the one who is distributing this. So now you understood the environment, right? RabbitMQ binds to port 5672. Then it is also having an UI application which runs on 15672. Let us bring the RabbitMQ up because that's the first server we need to bring it up, right? So I have a first tab. Let me do docker-compose ps. So it's up. Let me, sorry, I did before the session, I should have stopped it. I didn't stop. So I'm stopping the RabbitMQ. I'm exiting. Right. So this entire session is there in a GitHub repository, well documented within my limits. So you can just clone this. So if you see the GitHub repo, where it has all the documentation, how to bring terminology and stuff, source code, everything. You just clone the repo, and I just clone to this location. So I use Vagrant to start and stop virtual machine. So I will say Vagrant up, because I've said, right, I am running Vagrant in, sorry, I'm running RabbitMQ inside a virtual machine. So it is saying that machine is already up and blah blah blah. So you really need not to do anything. If it's a first machine, so it will bring the virtual machine up. It will install Docker Compose. I automated all the installations for you. So you really need not to do anything. Just download my repository and install Vagrant. You say Vagrant up, and you have VirtualBox. Then VirtualBox comes up. Then all the dependencies. Then send a Docker as a service. Everything runs. I have automated everything. So Vagrant SSH. Let me take shell to the virtual machine, so that I can start the RabbitMQ server. So now I took a shell, then let me switch to root. Then let me go to one folder. You can see the entire source code here. The whole crux is in the Docker Compose file. So this is a file which says the RabbitMQ, what to start, the Docker image. So we are saying that to start server and expose both these two. So the simple way is to run RabbitMQ docker-compose up -d. So -d means say it's run as a Docker compose up -d. We are saying that run the RabbitMQ as a daemon, so like a background process. It starts up and runs as a background process. It won't be attached to any terminals. So now it is running. Now, if you want to see logs of it, whether what is the state it is, Docker compose logs, you can see the logs saying that the MQ server started and stuff. And now, if you want to see Docker -compose PS, let me be PS, it shows the process states, and it is saying that it is bind to 5672, and 15672 is the ports that it is exposing outside. So let us access the UI of uh, let us access the UI of RabbitMQ localhost 15672. So here you can see the MQ service up overview. It shows connections. Still there is, as of now, there are no connections, so it's not showing them. One common thing what you need to do is, while the first time if you are logging, right, it will ask you a password. Okay, you give guest. So the guest is a default account. Just log in and you can see, okay, overview. It says about all we spoke, right? Connections, channels, exchange, and queues. Now let us bring our services up. So I'll go you overview about, you have seen the Docker container. Now I have to bring report API and mail client also up. This is an extension of my previous tutorials, right? So I have more microservices than what it should have for this demo, but that 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 explain you the complete landscape, right? So that's the reason. So now we know we have a gateway. Okay, I have to get to the gateway up on port 8080. Then I need a registry on 8672. Then I have EMP employee API, which similarly I have payroll API. If you follow my earlier tutorials, right, you all understand. This is like getting employee details, getting payroll details. Then I have report API. This is what is a producer now to MQ report API. Now we also have a email or mail client. Do understand this, mail client is not a REST service. It's just a Java program which listens on the queue and sends message. So it won't bind to anybody. These all guys will bind to prot. They all bind to registry. So, but mail client is a simple message bus consumer. It reads message from message bus and sends emails. It doesn't do anything. It's not a REST application or something like that, but it's a Spring Boot based application. So now the heart of this is like RabbitMQ, right? RabbitMQ. Now let me do the workflow. So I'm asking to give report. Browser is asking to give a report. Gateway calls report API, where report API does sync calls to these two. You already know this one, right? Sync calls. Okay. After getting employee details, it sends that message to RabbitMQ as an async pattern. Okay. I'm not going to cover. Few purist says that, okay, so report API calling a RabbitMQ, that's a synchronous call. That's what they say, because it has technology that RabbitMQ got. Yes, there is a synchronous nature in it. There is a non-blocking synchronous, which we are going to cover that. So very important concept. You get confusing about non-blocking synchronous calls. I'll explain you. Read about it. Just think this is an asynchronous call. Okay. So report API is giving it to RabbitMQ, and it just forgot. When mail API, what it is going to do is, right, it's going to read from RabbitMQ and sends email details. Then once again, report API responds back to the browser. So in a nutshell, our workflow is, right, when someone asks the report, user needs to get a report from in the web browser, and also an email and SMS also needs to send. The email and SMS is sent by the mail client. That is what the workflow is. So when an email or SMS is sent by mail client, So if the email server is down, you shouldn't really need to worry about it. Okay, that recovers and sends an email, and that recovers and sends an SMS. So that's the reason I made that mail service as an async component. Okay, so now we have RabbitMQ started. Now let us start all the individual components. So the first component, we have to start registry. Prior to that, you need to build the code. Hope this time it builds perfectly well, unlike my previous video where one of the background Java process got hang and it took me a while to figure it out. Yes, so if you see, right, we have how many microservices? 1, 2, 3, 4, 5 microservices, 6 in fact. So they work really well together. So now I built the code. You know that the artifacts were not there in the source code. I built them. Now let me start a registry. So the way to start registry is like you see java-jar registry, then the registry microservice gets started. This is the first microservice. Then we are going to start employee microservice. Then we are going to start payroll microservice. Okay, now we are going to start report microservice. Pay this attention to report microservice because this is the one which has to, it is a producer for the RabbitMQ. So it has to talk to the RabbitMQ. So if you understand, for RabbitMQ, report API is a producer, mail API is a consumer. So you see here that it binded to the RabbitMQ. And if you go to the RabbitMQ and see any connections were there, you can see that the one connection got created now. And there is a channel and there is an exchange. Okay, like the exchange needs to send message to this topic queue email is our queue, and exchange is sending the mails to the messages to that queue email. Okay, probably I might have used some good name. I thought queue mail I should have been more apt, but whatever it is. So exchange sends messages to the queues. That is nothing but routes messages to the queues. So that is what. So connections is nothing but a one virtual connection, which contains input and output. So sorry, connection is a TCP connection and channel is like a virtual connection, which has like input and output and exchanges. Then you have queues. So let us bring the client, then you will understand one more. The client is nothing but is going to read, right? So mail client or a consumer is now binding to RabbitMQ and trying to read messages. So it binded now. So if you do a little bit of refresh, so you can see that there is now a client came, a consumer came, right? Email consumer. So remember consumer group. When I'm explaining Kafka, I'll explain you consumer group better, but you just think there is a consumer which is attached to it. I can show you here also, that's fine. So now producer consumer communicated with the RabbitMQ. Now let me bring the gateway. So I started gateway as well. Let the environment get settled, all the microservices starts. So before doing a demo, I'll just walk you through the code and few things which you need to understand. So the main things is like, first we'll focus on producer. Who is our producer? Is our report API. So if you see the report API, this is the important thing. First you need to, because we are using Spring streams, right? Spring Cloud streams. Then that dependency unit, it's a simple Spring Boot application. Like if you see Spring Cloud stream starter Rabbit, this is a dependency which you need to add. So Spring Cloud starter stream Rabbit. So this is a library which helps to communicate with the RabbitMQ. This is a dependency you first add. Then I have a report controller, and this is the one I said, enable binding. Okay, so bind to the channel. Okay, so this is what an interface. Okay, so this is what we call it as a bindings. Uh, bindings is a collection of interfaces with input and output channel. So this processor is a channel. Okay, so in this processor you will have uh, input and output channels. So remember that output is we write and input is we read. So the first what it has to do, the when the report API needs to, the report API needs to send to message bus, right? So it's right. So you have to do a send to annotation and output. Pay attention to this 5 minutes, you'll get it very well. This is the most confusing thing. So you need to bind to a channel. So now send output process dot output is one channel, output channel. Your output channel is nothing but a pipe, message pipe, which will send it to the, so process send output. So you can see processor dot output, pay attention to this annotation, auto void. So this is what, and automatically a channel gets created here, a channel object. Here we are using channel object, and the channel object we are using output and send. So channel object is nothing but a processor, output and send. It's your object where you are trying to convert that into a some JSON with message builder. You just need to massage, you need to make it as a message to send, right? This is all the boilerplate code. So your employee object, you are converting into a message and sending it to the Kafka bus. So I'm not going to pay attention to this code. This is nothing but calling employee API, calling payroll API, getting those details, forming a full employee object, and giving it to the message bus. So all the report API is doing is like it is sending message to message bus. This is what is. Okay. So play with the code, you will understand. And this is a send to invitation. So these are the two things which you need to know to send message. So let us do a simple, I have, let us try to produce one message to message bus and see what is happening. So if, now I'm having a report API /100 and I say send. Okay. So it is communicating with the employee API, it communicated with payroll API, and it send message to message bus and it send it back to the browser as well. The same message it gave it to the browser and same message it gave to message bus. If you go and see the message bus UI, right, it's see one message it got. So the overview, it says that it got one message. So if you see like the, so one message was sent and one message was also read. So let us see whether our mail client read the message or not. You can see the mail client read the message. So the employee is 100 and his salary is, name is Alex and salary is 65. So the consumer read it, the producer, the report API produced it. So, and that information you can monitor on your RabbitMQ also. Even if you want to produce without the report API, right? You can simply produce saying that something like that. You go to queue. You can say I want to publish a message. You can say now I don't want. I want Alex to have 160. Sorry, 165K USD, something like that. You just send a publish a message. Message got published, and you can see that our mail client got the response. So this is decoupling, right? You not even need a report API to publish. In future, you wrote a new API which can publish, and so that mail client will not break. So, so this is one of the decoupling between mail microservices using message bus. Using message bus, you publish message to message bus. All the integrations happen smoothly. I showed you one example. Now, yeah. So we produce message using directly to the message bus and mail client read from that also. Let us go to the mail client and do a little bit of code walkthrough there. Yeah, before going that, I want to show you the configurations. You might be asking where this whole magic is happening. The whole magic is happening as usual in the Spring, this location. You just say that the destination is this and I'm using the Rabbit server is this. So Rabbit server is a local host which is running on 5672, its username and password. This is where all the magic happens in the producer. Similarly, the consumer, who is consumer? Mail client is a consumer, right? So like mail client, src main, you go to the application, the same thing. So the whole magic or whole configurations to use RabbitMQ is defined here. I need to region to queue email and consumer group. I'm going to come back and explain you what is consumer group, and I'll show you a small demo also. So now it is saying that it belongs to email consumer groups. Okay. Now then what my mail client, this simple thing. So enable binding. So bind to message system and using these channels, and I need to read data from input, right? I just read the data from input. Processor dot input, it reads data from input, serializes, control it to employee object and gives it. So even everything happens like a magic, which will sometimes makes us less confident because you really don't know what was happening, but that's perfectly fine. Abstraction will help you to focus on business logic. You as a developer needs to focus on business logic, not on the underneath nitty-gritties of messaging systems. That's the reason I love Spring Cloud Stream project. Okay, in future, if I want to switch from Rabbit to MQ, or I want to use cloud service like either from Amazon as a messaging system, I can go ahead with very little change in my application. So pay attention to this. This is what a consumer, stream listener. Listener is a consumer reading from input and converting it into a pure Java object, and we are getting the Java object. And this is how you can enable the binding. It's a Spring Boot application, and it is also a consumer application. You can do this. That's about the mail client. It's very simple program. It reads the message and just prints it on the console. So now we understood the producer consumer. Another thing is like if you have multiple consumers, what is going to happen? I have multiple mail client programs. Okay, let me do one thing. I'll run one more. So idea projects, Java jar mail. Sorry, Java jar mail client target mail client dot jar. So let us see what happens when I run one more. So now here what is happening is instead of one mail client, I have one more mail client trying to access the information from the queue. What will happen? So they are the duplicate should come to both, right? Mail client one instance. So when a message comes to queue, both try to read, both of them should be given. Yes, that is fine. It will have a duplicates. But here I get a consumer group. So what happens is I'm grouping the consumers so that duplicates are not happening between the consumers. That's very important when you have a group of consumers. One consumer for a scalability region, you have so many. Okay, but the duplicate shouldn't go to everyone. So the messaging system shouldn't send duplicates. So it should distribute messages across in the group. So consumer group helps to distribute messages across the consumers. Remember that consumer groups helps to distribute messages across the consumers in a unique fashion. No duplicates are sent to consumers. So if you understood that, that's all about consumer group. So you need a scenario where the duplicate shouldn't come to the consumers. So because you brought them for a scalable reason, you have 5 mail clients, so duplicate shouldn't come to 5 mail clients. And now I started it. Let me publish one message using UI. Now you see who got it. That's the first one. Alex got it. So let me send one more. Now you see here the second guy got it. Now let me ask to send Tom is like 101, I believe. So Tom's salary is 90K. This guy gets it. not this guy. So it got distributed. Though you have two consumers, the messages are getting distributed between them. That is what a consumer group. So this might be a, I know it's very tough to get in a single shot. Even I spent good amount of time in understanding this message bus asynchronous communication. Go to my blog, go to my Confluence page, go to my GitHub page, GitHub report, download the code, play with it. The best part is I try to make everything ready for you so that you can just play with and understand the concepts, then understand the code. And there are a couple of good books which I referred, and few pages where I refer to learn all these things. So these are all the reference pages you can really how do you pronounce Beltung, right? It's a very beautiful site for Java developers. Okay, you can go and see examples there. The purpose of this session is like explaining you an asynchronous communication with message bus using RabbitMQ as a message bus in a simple fashion. I created this whole session. Hope you might have liked it. If you have any questions, you just drop a comment. I'll try to get back to you. Thank you for watching.